Hi, today we're going to have a look at the NOCN Functional Skills Maths Level 1 sample paper, and we're going to start with the non-calculator section. Question 1. Estimate the answer to 39.856 times 7.421 by rounding to whole numbers. Write your answer in the box below. Okay, so they wanted to estimate, and we're going to estimate by rounding, okay, and it's to whole numbers. So let's start off. What can we round this number to? Well, at the moment, the whole numbers are the 3 and the 9, 39. So we look at the next digit, which is an 8. So if it's 5 or more, we need to round up. So what that means is we would increase this by 1. So instead of 39, this is going to become 40. If this had been a 4, for example, then we'll just keep it as 39. Okay, because we're saying what whole numbers is 39.856 between? Well, it's between 39 and 40, and we're just working out which one it's closer to. So we'll do something similar for this number, 7.421. Well, the whole number is 7, so we look at the next digit, which is a 4. Well, that's less than 5, so we can ignore all of that, and we'll just round it to 7. So they wanted us to estimate the answer to this. So instead of these rounded numbers, we can ignore those completely now, and what we want is 40 times 7. Okay. Well, the first thing we can do is we can ignore the 0. We will put it back in afterwards, but we can ignore it for now. So if we just think 4 times 7, well, you might find it easy to do 7 times 4 if you're better with your 4 times table. So that would be 4, 8, 12, 16, 20, 24, 28. So that's for the 4 times 7. And we got the 0. So essentially we're multiplying by 10. Just put a 0 on the end. Question 2. Find the mean of the numbers listed below. Okay, well, if we want the mean, we need the total divided by how many, or the frequency we can call it. Okay, so we need to add these all together first of all. In fact, what I'll do, I'll write it, how should we do it? Let's write it as a column. So we're going to have 4, 1, 6, 29. So I'm lining up my units down here. 3 and 23. Okay, you might want to do some at a time, or what we can do to add them up, instead of just working from top to bottom, we can see what numbers go together. Well, we've got, I know that 4 and 6 makes 10. 1 and 9 makes another 10, so that's 20. 23, and another 3 is 26. Put my 6 and carry my 2. Now on the 10s, we've got 2, plus 2 is 4, plus another 2 is 6. Okay, so we've got our total is 66. We want to divide it by the frequency. 1, 2, 3, 4, 5, 6 numbers. So 66 over 6, which is the same as 66 divided by 6. So we can do this using the bus stop method. How many times is 6 going to 6? Once. And 6 into 6 again is another once. So our answer is 11. Make that clear. Okay. Question 3. Show 1/4 as a decimal, then a percentage. Now with some of these, hopefully you'll know them just straight off the top of your head. So for example, if we add a half, then I'm sure you'd all know that a half is 0.5, which would be the same as 50%. Okay. With a quarter, if you can remember that, if you can think, oh yeah, a quarter, I know that's 25%. And then to turn that into a decimal, I need to divide by 100. So I'm going to move the decimal point twice to get 0.25. But if you can't remember, what you can do instead is say, well, 1/4 is 1/4. Or in other words, 1 divided by 4. So think, well, what would I do if I was doing a normal division? Well, I'd use the bus stop method. 1 divided by 4. So I'd put the 1 inside the bus stop and the 4 on the outside. Now it looks a bit strange. You think, how can 4 go into 1? Well, it can't. But if we put a couple of zeros in here, doesn't matter how many zeros for now, we can always add them. We say, well, 4 doesn't go into 1, so let's carry the 1 over. So what we need to do on the top is put a 0, because 4 went into 1 0 times. And keep our decimal point in line. Now we can say, how many times does 4 go into 10? Well, we've got 4, 8, so that's twice. And then 9, 10, that's 2 left over. So how many times does 4 go into 20? Well, 4, 8, 12, 16, 20. That's 5 times. So that's how you can get your decimal if you don't know it off the top of your head. And then to turn the decimal to a percentage, we're multiplying it by 100, so we're moving that decimal point twice to get 25%. Okay, but obviously you can see it's much quicker if you can learn some of these: a quarter, a third, a half. Some of those ones are really handy to be able to just pull out of the air. Okay, question 4. Calculate 5% of £300. Okay, well, you could do 5 divided by 100 times 300, but what I'm going to do instead is I'm going to start off and say, well, I know that if I want 10% of a number, especially if it ends in a 0, I can just take a 0 off. So that's going to be £30. Well, if I want 5%, 5% is, well, 5 is half of 10. So 5% is going to be half of 30. So we want 30 divided by 2. I'll just explain that again. So if 10% is £30, 5% would be half of that, because 5 is half of 10. Okay, so 30 divided by 2. Again, we can use the bus stop method. Put the first number inside the bus stop, 2 on the outside. So, does 2 go into 3? Well, yes. How many times? Well, just the once. Because if we had 2 2s, it would be 4, it would be too many. So 2 goes into 3 once, with 1 left over. What about 2s into 10? 2, 4, 6, 8, 10. That's 5 times. So our answer is £15. Question 5. A sports shop records its sales figures for the last 5 months. May sales are 72,520. And then we've got the sales figures for January, February, March and April as well. Add the May figure and place sales figures in order, starting with the highest. Write your answer in the grid below. Okay, so the first thing we need to do is to write this as digits. So use the commas to split it up. So we've got 72,000. So we've got 72,000. So we can put a comma for the 1,000. And then we've got 520. There we go. Right, now we want to order these figures starting with the highest. So what's the biggest one we've got? Well, 2 of these have got hundreds of thousands. We've got 135,000 versus 109. So that's going to be the biggest. Then this one. Then again, we can just look at the tens of thousands to start with and see which is the biggest. If you want, you can write them in a column, one above the other, and then it's easier to spot which is bigger. But because we've not got too many, I'm going to say, well, we've got 87, 52, 72. Well, 87 is the next biggest, so that'll be third. And 72 is bigger than 52, so that'd be 4, and that'd be 5. Now we just need to write them in the grid. So the biggest was 135,700. Then we had 109,600. then 87,300, 72,520, and finally we had 52,525. Question 6. Sharon gets a total of £1,050 each month. She spends 3/10 of this on rent and 2/3 on food and bills. How much money does Sharon have remaining? Let's move it up a little bit for us. Okay, so what we want to do is find out what 3/10 of this amount is, then find out what 2/3 of this is, and then take them both away from the total to find out what's left. So if we want 3/10 of 1,050, let's start off by working out what 1/10 of 1,050 is. Well, 1/10 is 1 divided by 10. So in other words, it's going to be 1,050 divided by 10, which if we do it with the bus stop method, we're doing a lot of bus stop method today. What we can do with this is we've got the zeros on the end, so actually we can just say, well, dividing by 10, just take the 0 off. So actually I don't need to do the bus stop method. We can just say, well, that's £105. But we don't want just 1/10, we want 3/10. So we're going to need to multiply this by 3. So 3 5s, 5, 10, 15. 5 carry the 1. 3 zeros, 0, but we got the 1 carried that we need to put in. And 3 times 1 is 3. So we've got £315. Now we also want 2/3 of 1,050. Again, let's start off with 1/3 of 1,050. So with this one, we do want to do 1,050 divided by 3. So this time I am going to do it with the bus stop method. So does 3 go into 1? No, it doesn't. I could put a 0 up here. In fact, I'll put a 0 to show it's going no times, but we don't have to. So instead we say, well, we're sort of carrying the 1. So if you want to write the 1 here, you can. Or we can just say, well, how many times does 3 go into 10? 3, 6, 9. So that's 3 times and 1 more to take it up to 10. So 1 carried over. How many times does 3 go into 15? 3, 6, 9, 12, 15. So that was 5 times. And how many times does 3 go into 0? Well, it doesn't, so that's 0 times. Okay, so we've got an answer of £350. Now, again, that was for 1/3. We want 2/3. So we're going to multiply this by 2. Well, 2 times 0 is 0. 2 times 5, 5, 10. 0 carry the 1. And 2 3s, 3, 6. Add the 1, gives us 7. So in total we've got £700. So she's spending £315 on rent, £700 on food and bills. So the total spend is going to be 315 plus 700. So 5 plus 0 is 5. 1 plus 0 is 1. 7 plus 3, we've got 7, 8, 9, 10. So we've got a total of £1,015. That's what she spends. So how much money does Sharon have remaining? Well, for that, we need to start with our total, 1,050, and take away all the money that she spent. Okay, you could do a bit of a shortcut on this, because you could say, well, if I've got 1,050 and I'm taking away 1,015, well, I could just take 1,000 off both, and you could just do it as 50 minus 15. But we'll do it this way, and you'll see that you get the same answer. So 0 take away 5, well we can't take 5 away from 0 or nothing. So we're going to reduce a 5 to a 4 and pass a 1 over there. So 10 take away 5 is 5, 4 take away 1 is 3, 0 take away 0 is 0, 1 take away 1 is 0. So we get our final answer of £35. And that's the end of the non-calculator section. Okay, so now we're going to look at the calculator section. Okay, so they don't start the question numbers again, they continue them going. So it's question 7 of the overall paper. Dave owns a shop. He buys 20 boxes of chocolate bars from a wholesaler to sell in his shop. Each box contains 20 bars. 47 bars are damaged. Estimate what fraction of bars can be sold. Show the fraction in its lowest form. Show your working out and write your answer in the box below. Right, so we've got loads going on here. We're trying to find out what fraction of the bars can be sold. Well, to start with, we want to know how many bars there are. Okay, so he's buying 20 boxes and each box has got 20 bars. So in total, there's going to be 20 lots of 20, or 20 times 20. So you can use your calculator, or you can say, let's ignore the zeros, 2 times 2 is 4, and then put the zeros on. Let's say, you can use your calculator to check as well. So we've got 400 bars in total. 47 bars are damaged. Now it does say estimate what fraction. So when we're estimating, usually we're going to be rounding. Now, we don't need to round 400 because that's a nice big round number. But what about 47? Well, we can round that to the nearest 10 maybe. So the 4 is the tens at the moment. So we look at the next number. If it's 5 or more, we round up. So we're going to round that to, so we can put 47 is approximately equal to, and that's going to round up to 50. So we've got the 7, which means we need to increase that by 1. Okay, so what fraction of the bars can be sold? Well, it's going to be, if 47 are damaged, or we're now saying 47 is 50, rounded to the nearest 10, we want to know the ones that can be sold. So we're going to need the 400 minus the 50. That's going to tell us how many good ones we've got. So now we can use a calculator. 400 minus 50 to give us 350. Okay. So we want it as a fraction. So it's going to be 350 out of 400. Okay. Show the fraction in its lowest form. You might see that as simplified to its lowest terms or something like that. All mean the same thing. Basically get this to have as small numbers as possible. Well, if we've got 0 on the top and bottom, we can take those off. So we've got 35 over 40. Now we need to see, are there any common factors? So is there a number that goes into 35 and also goes into 40? Okay, well, I know that if a number ends in a 5, I know that 5 goes into it. And if it ends in a 0, well, 10 goes into it, which means 5 also goes into it. So we can divide both of these by 5. So if we do that, we can do the 35 divided by 5 is 7 times. And the 40 divided by 5 is 8 times. So there we go. Question 8. Paulina is planning a forest walk for her walking club. They will walk from point A, up here, to point D, which is over here. They will need to stop for a water break at either point B or point C. It says either, so they don't have to do both, just one or the other. And down here we've got a scale. 1 centimetre equals 5 kilometres. And the question is, what is the length of the shorter route in kilometres. Okay, so if it's the shorter route, we kind of need to work out both really. So we're either going to go from A to B and then on to D, so maybe we can call this option 1, or we can go from A to C and then on to D. We can call this option 2. Okay, so what we want to do is we want to measure these then really. So this we've got this. I make that about 7.8 centimetres, I think. And down here we've got 4.3, I think, 4.3 centimetres. Now over here we've got 5.6, I think. And down here we've got 5.2. So route 1 is going to be 7.8 plus 4.3. And we get 12.1 centimetres. And then option 2, we've got 5.6 plus 5.2. Let's write that out in full. And that's 10.8 centimetres. Okay, we want the length of the shorter route, which is this one, because 10.8 is less than 12.1, so that's shorter. But it does say, what is the length of the shorter route in kilometres? Well, if 1 centimetre equals 5 kilometres, then we're going to need to multiply this by 5. Oh, we've still got it in there, so multiply by 5. So we've got 54, and that is now in kilometres. Okay, so our answer, so we can say what route it was. So the route we chose was 2, so it was the ACD route. So we can put ACD, and that was 54 kilometres. Question 9. A youth centre spends the day strawberry picking. The tubs of strawberries are weighed individually. It's the weight of strawberry tubs. So 570 grams, 1 kilogram, 0.43 kilograms, 1,200 grams, and 600 grams. Calculate the total weight of the strawberries. Give your answer in kilograms. Okay. Show your working out and write your answer in the box below. So if we want to do it in kilograms, what we need to know is that there are 1,000 grams in 1 kilogram. Now we could turn these all into kilograms because our final answer is going to be in kilograms, but I actually think it's easier to work in grams so that we don't have the decimals. So if you choose to do it in kilograms, that's fine, but I'm going to leave my 570 grams, and I'm going to say, well, if this is 1 kilogram, I know that that's equal to 1,000 grams. These two are in grams, so that's fine. 0.43 kilograms. Well, if I want to turn that into grams as well, I'm going to do 0.43 times 1,000. Let me check. 43 times 1,000. I think I only did 2 zeros. Yeah, 430 grams. So now we want to add these all up. So we've got 570, so we're doing all the grams. Add up the 1,000 plus the 430 plus 1,200 and finally plus 600. So we've got a total of 3,800. That's grams. Now we can convert it back into kilograms. So now we can divide it by 1,000. And that gives us 3.8 kilograms. Question 10. Jason is a delivery driver. He starts and finishes at the warehouse. Each delivery stop that Jason makes will take 20 minutes. Jason has 3 deliveries to make. Jason's average speed is 40 miles per hour. Use the formula time in hours equals distance in miles divided by the average speed in miles per hour. Okay, so we've got a picture here. So this is the warehouse, that's delivery 1, that's delivery 2 and delivery 3. Okay. Jason leaves at 9 a.m. What time will Jason get back to the warehouse? Show your working out and write your answer in the box below. Okay, so we want to know what time he'll get back to the warehouse, so we need to know how long this route is all going to take. Okay, and they've given us the formula, so they said it's the distance in miles divided by the average speed. Okay, well, let's work out, in fact, we've got the average speed is 40. So what we do need to work out is this distance. So it's going to be all of these added together. So it's going to be 37 and a 53 and a 40 and then finally 20 miles to get back to the warehouse. And that gives us a total of 150 miles. Okay, so we've got our time was the distance, the 150, divided by the average speed, which they told us was 40. And we can use our calculator. And that gives us 3.75. Now that's in hours. Okay. If we want to turn it into minutes, we need to multiply it by 60. Which is 225 minutes. If you wanted, you could do 0.7 of 60 and get it in hours and minutes. But you see, the reason I'm putting it all in minutes is because we need to add on the stops that he makes as well, because it says each delivery stop that Jason makes will take 20 minutes. So we're going to add on 20 for the first delivery, another 20 for the second delivery, and another 20 for the third delivery. So if we now add on these 20 and 20 and 20, we get 285 minutes. Okay. Now we want to turn that into hours and minutes. So you could do it in a different order. Doesn't matter how you're doing it. This is a method. There's more than one right method. So what I'm going to do is say, well, how many hours are in there? Well, I'm just going to keep taking 60 off, so that's 1 hour. Can I take another 60 off? Yes, that's 2 hours. Another 60, that's 3 hours. So 1, 2, 3. We can still take 60 off, so that's 4 hours. So it's 4 hours, and we've got 45 minutes left. So all we need to do with that now is to add it on to our starting time. Well, Jason leaves at 9 a.m. and we've got no minutes. So what we've got is we've got 9, 0, 0. And we want to add on 4:45. Well, 9 and 4. You can use your calculator, but we've got 13. And this is just going to be 40. I'll do it to show that it's hours and minutes. It's not a decimal. So it's 13 hours, 45. Sorry, this is the time, isn't it? So it's 13:45 o'clock, if you like. They've got AM, so we're using a 12-hour clock here. So what we want to do to turn this into a 12-hour clock, we need to take off 12 hours. So 13, take away 12. So that's going to give us 1:45. And because it was 13, it was over 12, so we know it's in the afternoon. So it's 1:45 p.m. Question 11. Aaron takes 40 minutes to run 5 miles. He wants to use this information to estimate how long it will take him to run a half marathon. A half marathon is 13 miles. Well, it's a tiny bit more, but for this question, they're saying it's 13 miles. What is the estimated time Aaron will take to run the half marathon? Give a reason why this estimate may be unreliable. Show your working out and write your answer in the box below. Okay. Well, the estimate is going to be, if he does 40 minutes to run 5 miles, well, let's find out how long it would take him to run 1 mile. So if we do 40 divided by 5, so that's going to be 8 minutes for 1 mile. We've got 13 miles, so we want 13 lots of 8, which gives us 104 minutes. And if we want to convert that into hours and minutes, we can take off 60 for an hour. So it's 1 hour 44 minutes. Okay. So that's our estimated time. Give a reason why this estimate may be unreliable. Well, he did that for 5 miles. 13 miles is a lot longer, so Aaron may not be able to run at the same speed for the longer distance. Okay, you might have other reasons, but that's probably a nice straightforward one. Okay. Question 12. A school needs to cut the grass on the playing fields. They have found 2 companies who offer a grass cutting service. We've got Fresh Cuts, who have a fixed price of £250, and we've got Green Gardens, and their grass cutting is 4p per square metre. Okay, so it depends on how big your lawn or your patch of grass is. So, and we've got the diagram below is a plan of the playing fields, which shows everything measured out in metres. And if we have a look at the actual question, which company is the cheaper option for the school? And this is 6 marks. Okay, so we're going to need to work out the total area of the shape. We're then going to need to work out the cost, if it costs 4p per square metre, and then we need to compare that to the other company to see which one's the cheapest. Okay, so what we can do with this shape, well, there's not an easy way to work out the area of a shape like this, so what we're going to do is split it up into some smaller shapes. So I know how to work out the area of a rectangle. So if I put a line across here, I've now got 2 rectangles. In fact, I'll write it down. Area of rectangle is L times W. Let's draw a little sketch where L is the length and W is the width. So for example, the area here is going to be 106 times 31. Hope it's not too dark on there. So we've got 3,286 meters, and it's meters squared because it's area. Now, what about this rectangle here? Well, we've got the length is 60. Now, what about this distance? Well, we haven't got this distance at the moment, this across at the bottom. We know the full length across here is 106 meters. We know this is 18 and this is 47. So this gap must be the difference. So what we can do, if we add 18 and 47 together, we get 65. So that's those two distances. So this must be the difference. So it must be 106 minus 65, which is 41. So I'll put this in here. So the area of this rectangle is going to be 60 times 41, which gives us 2,460, and again that's meters squared. Okay. So that means that the total area is going to be the area of that top triangle. So 3,286 plus the area of the bottom rectangle, which is 2,460. Which gives us 5,746 meters squared. Right, so we've got the total area. Good. Now we want to know the total cost. Well, we know it's 4p per square meter for the second company. So if we multiply it by 4, we get 22,984. But remember, that's p, or pence. If we want to turn it into pounds, well, we're going to need to divide it by 100. Okay, so if we divide that by 100, we get £229 and 84 pence. Okay, but we don't need to put the p or the pence because we've got the pound sign. Now, the actual question was which company is the cheaper option? Well, we can say that £229.84 is less than £250, which was the price of the other company. So this was the second company, which was Green Gardens. It's cheaper. Okay. And just to check, yeah, Fresh Cuts was the fixed price, Green Gardens was this price. Okay. So it looks like if you've got a smaller area, then this one's going to be cheaper. If you had a much, much bigger area, then you'd probably be better off paying the fixed price. Question 13. Calculate the volume of the cuboid below. Give your answer to 2 decimal places. Well, the volume is the length times the width. So a bit like a rectangle, but then we've got a third dimension, so it's also times the height. In other words, multiply all 3 dimensions together. Okay, so we said the length is 9.58. The width is 4.53. And the height is 3.76. Now, it doesn't matter if you call that the length and that the width. So long as you're multiplying them all together, it will give you the right answer. So we've got 9.58 times 4.53 times 3.76, and we get 163.17422. I've written all the digits out, but we have been asked to give your answer to 2 decimal places. Well, this is 2 decimal places, so we look at the next digit, which is the 4. Well, it's less than 5, so fine, we can just leave that and keep our answer as 163.17, and it's volume, so we've got to think about the units. Well, it's meters, and volume's at 3 dimensions, so it's meters cubed. Question 14. Anne looks at her bank statement online. It shows she is overdrawn. The account balance is minus £375.20 because it's money she hasn't got. She owes the bank. Anne knows her monthly wage of £1,525.80 will go into the account today. What will the balance on the account be after the payment has been received? Show your working out and write your answer in the box below. Okay, well, probably the easiest way to think of it is just, well, I'm starting at minus £375.20, and then I'm going to add on £1,525.80. So, with your calculator, we can put in 375.20, and we can use this to make it a negative number. And then add on 1,525.80. which gives us 1,150.6. But because it's money, we're going to have 2 decimal places for the pence. Okay, question 15. Rob is looking at sale numbers for his new brand of ladies' shoes in the last year. He records the information in a table. So there were 63 orders for shoe size 4, 82 for size 5, 135 for size 6, and so on. Use the space on the next page to draw a suitable chart showing Rob's findings. Okay, so normally if we're drawing a chart, it's likely to be either a bar chart or a line graph. Now, if we've got distinct categories, so we've either got size 4 or 5 or 6, we haven't got 4.5 or anything like that. So a bar graph is going to be better because we've just got one value for each bar. Okay, so we've got our bar graph or our graph paper over the page. Okay, so what I'm going to do to start with, I'll do the easy bit first, which I think is the shoe size. So right down at the bottom. In fact, it's up to you if you want to start on the graph paper or start at the side. It really doesn't matter. I'm going to start here as my starting point, but measure it out first of all. So we had shoe sizes 4 to 9. So if I do it this way, we could have 4, 5, 6, 7, 8, and 9. Yeah, so that works. So this is going to be shoe size. We're going to have size 4, 5, 6, 7, 8, 9. And then we've got the number of orders. Now what we want to look at, if we flick back over to the other side, is, well, what's the biggest number of orders? Because that's what we're going to use to make sure the graph goes high enough. Well, the biggest number, 159 is the biggest, okay? So we're going to need to go up to 159 at least, okay? If we go more than that, that's fine. So we can think about, well, of all these boxes here, what scale do I need to use? So you could say, well, we've got 10 boxes here, so we could say, if I move it down, 10, 20, 30, 40, 50, 60... 70, 80, 90, it's going to go off the page if I do one little box for each order. So maybe we can think, well, instead, what about if we make this half, or like we fit twice as many? So maybe you go up in 20s. So that's going to be 0. We could say 20, 40, 60, 80, 100, 120, 140, 160. Yep, that'll work. We needed to go up to 159, so 160 is going to be high enough. So let me get my ruler. Put this in. Okay, so we know that was 160 up there. Let's start at the bottom. So we had 20, 40, 60, 80, and then 100, 120, and 140. And we can put we can put a title in here. We can put orders by shoe size. Normally I'd do the title at the end, but it was convenient to do it now, so then we won't forget. Right, so now we need to do the actual plotting on here. So for shoe size 4, again if we flip over, we had 63 orders for size 4. Right, so 4's down here, so 20, 40, 60. Now this is where you can easily make a mistake. You might go 1, 2, 3 for 63, but remember, each one of these boxes isn't one order. And actually I'll put in number of orders. Okay, because we said that this is 20 orders, well, we've only got 10 little boxes. So you've got to think 20 divided by 10 is 2. So that means each of these little boxes is 2 orders. Okay, so if we want 63, well, that would be 62, 64. So 63 is going to be halfway in between there. Yeah, so halfway between 62 and 64. Now for shoe size 5, we've got 82 orders. So here's 80, so one little box would take us up to 82. Shoe size 6, we've got 135 orders, so we need to move this down. Here's 120. Well, 130 would be halfway in between. And then 132, 134, 135. So again, it's going to be half. We want half a square. Okay. For shoe size 7, we've got 114 orders. So let me show you. So here's size 7. So we're up on this column. 110. Sorry, here's 100. 110 would be halfway. 112, 114. Then for size 8, we've got 92 orders. So we're over on this column now. We've got 80 here. 90 would be halfway. 92 is going to be one box up there. And then finally, for shoe size 9, we've got 159 orders. Okay, so we can start at 114 to 150 would be in the middle and count up. Or we can say, well, 159, that's one down from 160. But remember, one down is just half a box. So we're going to have a line across here. Now, see, I just did well, that should be in the middle. It's a little bit closer to the bottom, but I want it in there. Okay, they'd be all right with that. I think that's clear enough. We want them. I'm just making it messy. 159, just so it's clear. Okay, so I've just done the lines at the top, and then I tried to be nice and efficient and draw my vertical lines in one go. Okay. Now, some people like to have their bars not touching, which is fine. I do mine touching just because it's easier. I can do fewer vertical lines. So long as all your bars are the same width, that's what we want to see. You don't want some skinny ones and some fat ones. Okay. Right, so you can't see it all on one page, but we've got a title, we've got our bars, we've got a label on the y-axis and a label on the x-axis. Question 16. A student rail card gives 15% off the original price. Sue uses her rail card to buy a ticket home. The original price is £120. How much will Sue pay for her train ticket using her rail card? Well, if it's 15% off, we can do 15 out of 100 times 120. So this tells us how much the discount is. Which is £18 off. So we then need to do 120 minus 18, which gives us £102. If you want to do a bit of a shortcut, what you can say is, well, if it's 15% off the original, well, 100 minus 15 means I'm going to have 85% left. So we could just do 85 out of 100. So this is or, so this is like an alternative method. If we do 85 out of 100 times 120, we also get £102. Just alternative. This is nice, especially as you move on to level 2. It's a bit quicker, but there's nothing wrong with doing it this way. Question 17. Trying to fit the question on as well. At a party, the children are playing a board game. They have to spin the arrow to know how many spaces to move. Okay, we've got lots of different numbers around here. What's the probability that the arrow will land on the number 5? Show your answer as a fraction in its simplest form. Okay, well, let's start off with the denominator. How many possible outcomes are there? So how many spaces? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be out of 10. How many of them are the number 5? Well, we've got 1, 2. So it's 2 out of 10. They want the answer in its simplest form. So what number goes into 2 and 10? Well, they're both even numbers, so we can divide by 2. So 2 goes into 10 once. Sorry, 2 goes into 2 once. And how many times does 2 go into 10? Well, let's check. 10 divided by 2 is 5. So 1/5. Then we've got a part B to this question. Which number has the highest probability that the arrow will land on it in the board game? Okay, well, the number with the highest probability is going to be the number that occurs the most. Okay, so let's do a little table actually. So if we do number, NO could be short for number. And then we can say frequency. So, well, let's start with the smallest number so we don't forget them. So 1. So number 1, we've got 1, 2, 3 of them. What about 2? We've got 1, only 1. So the number 2 occurs once. The number 3, we've only got 1, 3. Yeah. What about number 4? We've got no 4s. You could put 4 and a 0. Look, let's be complete. Number 5. Well, we know we've got 2 number 5s. Number 6. We haven't got any. Number 7. There's 1 7. And number 8, which I think is the highest number, we've got 2 8s. Now we can check this because it should add up to our total, which is 10. So let's use the calculator. So 3 plus 1 plus 1 plus 2 plus 1 plus 2 is 10. Good, so we've got all of them. They wanted to know the number with the highest probability of it landing on. Well, 3 is the biggest. Okay. Well, 3 is the biggest frequency, which relates to the number 1. So which number has the highest probability? 1 has the highest probability because there are more of that number than any of the others. Okay. Question 18. Draw a net of the cube below. Use this space for your drawing. Okay, so each of these squares is 1 centimetre. Sorry, I mean these small squares is 1 centimetre. These big squares are 3 centimetres. So for each face of this cube on the graph paper, we're going to need 3 squares each way. Now with a cube, think of it like a dice. With a dice, the numbers go from 1 to 6. We've got 6 faces on the cube. Okay, now there's different ways to draw a cube. The way I prefer to do it is as a cross. So let's start over here. So we're going to have 3 squares down, 3 squares across, 3 squares up, 3 over this way. Okay, so what we want is 1, 2, 3, 4 squares, so they wrap together to sort of form the body, and then we'll have a square at the top and a square at the bottom. Okay. So I've gone 1, 2, 3, draw a line, 1, 2, 3, another one here, and then 1, 2, 3, another one here. This is good. If you're not very comfortable with this, then it's good to get a box, get like a cereal box. I know it's not a cube, it's a cuboid, but it's the same idea. So we've got our 4 sides, so they're all wrapped together, and then we can have a square on top for the lid, and a square at the bottom for the base. And there we go. And finally, question 19. So we've got 29, and then it's just written next to 42 divided by 3 in brackets, plus 16. Well, if you see a number next to a letter or next to some brackets, it means there's an invisible times in there. But if you remember your BIDMAS rules, well, whatever's in the brackets needs to be done first. Okay, so we're going to work this bit out first, but we've still got the 29. So we're not doing anything with the 29, but we're going to work out this answer and put it here. So 42 divided by 3 is 14. So instead of 29 times this set of brackets, we can now have 29 times 14. And we don't need the brackets anymore because we've done the calculation. And we've still got plus 16. So with BIDMAS, we've got B for brackets, so we've done that. I for indices, so like squares or cubes, we haven't got any. D for division, we've done our division. M for multiplication, yep, we've got multiplication, so we're going to do this before the addition. So 29 times 14, or you can do it 14 times 29. So we've got 406, and we've still got the plus 16. Try not to be tempted to do it all in one go. It's much easier if you do one step at a time. Then if you do make a mistake, it's easier for you to spot, but also it means that you can still get marks for your workings. So we get a final answer of 422. So that's the end of the paper. Please like the video, give your thumbs up, subscribe to the channel so you get notified when I add more videos, and I look forward to seeing you again soon. Thank you.